Hey guys, and welcome to my course where we will build from scratch a complete Guess the World, also known as Hangman game, in Java by using Spring Boot, MySQL, and Java Swing technology. Under the following sections, you will get to interact with various aspects of building this game, such as defining the ecosystem of working with Spring Boot framework, one of the most popular frameworks on the market, and also you will manage to create the app in the modular way, such as each feature is separated in a corresponding package. We will define several components as part of this game, but don't worry, since I will show you exactly on how to make them interact with each other. Last but not least, since it's a hangman simulator, we will need to store somewhere the words. For this, we'll add the data under the MySQL relational database. So, let's get started. The first step in our development process is to create a Spring Boot application. So I went to start.spring.io, and over here you see that you have several options that you can choose. The project type, the Spring Boot version, the Java language, and now for the project metadata. We can set up a specific group, and we will call it com.hangman. For the artifact, we will name it game. Same for the name. On the description, we can call it Hangman Game Simulator. For the package name, we can go with Hangman Game, the packaging jar, and for the Java version, we choose the 11 version. We also have the ability to add specific dependencies, but for now we should not go into this direction since those dependencies will be added in a manual way at a later point in the course. So we can go to generate the project. Let's open this folder. Actually, let's extract the zip into a specific folder. Okay. And let's cut this folder under the projects over here. Of course, you can choose whatever location do you prefer. So now we have the option to import this Maven project into our IDE. Okay, and the next step will be to create the corresponding packages that we'll use as part of this course. So this is the base structure of the packages. So let's call this package Hangman Game, Guy and Frame from the graphical user interface. A new package called Hangman Game, Guy and Listeners, where we will store our corresponding listeners. Another package for menu. I'm setting a new package now for the panels that will be added to the main frame of the application. So I'm trying here to structure as much as possible this project into different sections. Let's create a package called model. Another one for repository where we will store our Spring Data JPA corresponding repository. One for service, where we'll keep our main business logic service. One for the service IMPL. Under the service we will have an interface, and under the IMPL we will have the corresponding implementation. And one last package for util. Over here next to the Spring Boot starter dependency, we have the option to add a new dependency here. Let's set up the group ID for the org, Spring Framework, boot. And the artifact ID will be Spring Boot Starter Web. Since I actually want the Tomcat instance to run behind the scenes, so the application will be up and running without any user interaction. So let's start the application now. We will choose Spring Boot app, and the Spring Boot application will start using an embedded Tomcat instance. And we have the option to check this. Let's go to our browser and type in localhost 8080, and we will see a default error page. Now, since we have the main structure of the application set in place in terms of packages, we should start building our actual components. So the first step is to navigate under Con Handman Game Guy panels and create a simple class, and let's call it empty panel. The first thing is to annotate this class with the component stereotype so that it will be registered with the Spring as a simple component and can be injected later in the corresponding frame. This class will actually extend the JPanel. This is helpful for us in order to create the actual panel as a separate component. Now let's add a simple constructor, and we have the reference to the JPanel using the keyword this, and we want to set the preferred size to a specific dimension, 500 per 100. Let's also set the background color of the panel to black. And we can set up a simple layout for our panel, and let's go with a grid layout. Two and one. I stopped the initial running of the application. Now, since we have this simple panel in place, we can go to the Com Hangman Game Guy frame and create the actual frame of our application that will keep all the panels. Okay, we can click on Finish button. Also for our hangman frame, we should annotate it with component so that it will be picked up by the spring. This class will extend the JFrame. JFrame is a class from the Java Swing package. And we have the option to auto-wire the empty panel. Once again, since empty panel is a component, we can inject it directly here. And we'll also create a JPanel called main panel. Let's also add a comment, since this main panel will keep all our imported panels that will be added to the main JFrame. So imagine that we will import all our created panels, add them to the main panel, and this main panel will be added directly to the JFrame. We also set up a simple constructor. And let's create a method called createMainGuy, and we'll need to annotate it with a post construct so that this method will be automatically invoked. We imported the Javax annotation package in order to properly use the post construct annotation. And now we will define some specific properties for our main JFrame. We'll need to set up the bounds to 100, 70, 1100 and 500. We will not allow the user to resize this JFrame as an option. The next step will be to add a specific window listener to this JFrame. We'll need to instantiate a Windows adapter. Let's remove these comments. And we'll need to implement the corresponding method called window closing. And as a parameter, this will receive the window event. And when the user will click on the X button in order to close this window, we'll actually get rid of the application, we'll exit the application and release all the resources. Now we need to instantiate the main panel. And under the main panel, we need to set the layout. And for this case, we will use the border layout. And now we are able to add an empty panel under the main panel using the border layout south option. So this empty panel will be added in the bottom. And we'll also add the main panel to the JFrame, the main JFrame, and set the JFrame as visible to the corresponding user. Now let's start the application. Let's save the empty panel. And you see that we received an error. Spring does not work well with swing corresponding components. And you see the error here that is related to headless. In order to fix this, we need to navigate to the main corresponding method from our game application, and I remove the initial statement, and we will need to use the Spring application builder. I will create a new object for the Spring application builder, and as an instance we will receive the game application.class, and we need to set the headless for the builder as false and run this builder. And we are now ready to start the application, since the headless option was set to false. And you see here at the bottom we set the empty panel, and we also have the option to close the JFrame. Now, before starting to build the next panel in our list, the images panel, we need some images to play with. So I set up for you two images, one for smile and one for sad. And the first thing to note is that we need to create a folder under the source main resources, and let's call it images. Don't worry, I will provide you both the sad and the smile images to work on this project with them. So this being said, let's create the next panel in our list. So I set up a class called images panel. This class will need to be also annotated with a component so that it will be picked up by the Spring container. And same to the empty panel, we need to extend the J panel. Let's remove these comments. We need to set up a list of G labels. Let's call it images list. This will be used in order to store our images. Now we will create a simple constructor called images panel, of course, and the method that will be annotated with a post construct, so that it will be invoked automatically by Spring in order to set up all the properties for our images panel. The first thing will be to instantiate the images list as an array list. And also set the preferred size to 100 and 100 as a dimension object for our JPanel. Let's fix this since it's not called images, it's actually the images list. Okay. Let's set a specific background color for our panel as white. And we will also set a specific layout as grid layout with 5 rows and 1 column. Let's set up some space here. Now I would like to do a for loop from starting from 0 to 4 inclusive, so less than 5, and we'll create a J label. Imagine that we need to store 5 images. So we created some simple objects for our J label. Let's also go to the com hangman game util and create a simple helper. Since I would like to store some references to both smile and sad images under this helper class, so I annotated this class with component. And let's set up some simple image icons. So this will be an image icon that will have a reference to the smile image. So we need to create an image icon, and we'll use the helper class get class loader, get resource, and if you recall, we set up the image under the images smile JPG. And let's also do something similar with the sad image. New image icon, the same process, helper class get class loader, get resource, images now sad.png. So we have a reference to both these images. And now let's go to the images panel, and over here as a parameter to the JLabel constructor, we can actually use the reference to the helper smile image, since by default our images will have the smile corresponding type set to them, and get image. But you see that we receive an error, so we need to somehow transform this reference to a specific format that the JLabel will actually be able to properly use. In order to do this, let's create a simple method that will return an image icon, let's call it scale, that will receive the image source as a reference, and basically from this image source, from this image, it will return an image icon. We'll set the width and height to properties to 50. Another variable for the type and the type will be buffer image type int RGB. And now let's create a buffered image called DST from the destination. New buffer image that will receive the width 50, height 50, and the type as the type int RGB. We'll need to use the graphics 2D, and based on the buffered image destination we'll invoke the create graphics method. Now we will be able to draw an image from the graphics 2D object, and will be the source 0, 0, the width, height, and this. And we'll also need to invoke the dispose method on the graphics 2 object. And as a final step, we can return the image icon from this method. So over here, we just need to use the scale method, and you see that the issue has been fixed, and that J label will actually point to a image icon for the smile image. And we need to also add the image label to the images list. Let's format a bit the code. Okay. And let's go back to the Handman frame, since we already have this images panel in place. Let's inject it using the auto wired annotation. Private images panel, and similar to the empty panel, you can add it to the main panel. This main panel add images panel, and we'll use the border layout as for east. So this will be stored in the right part of the screen. Let's start the application. And you can see that the images panel has been set up. Let's close this instance. And let's move this console to the bottom of the screen. Before moving on and start to implement the third panel in our list, we will need to set up some specific components, classes, as part of our development process. So I went to hangman gameutil package, and let's create a class called spring context. Click on finish. We'll need to annotate this class with a component stereotype, and let's also add a descriptive comment, such as this component will be used to auto-wire the Spring application context inside the non-Spring corresponding class. You will see at a later point in this course how this class will be used. So Spring Context needs to implement the application context aware, We'll also use the auto-wired annotation. And let's add a variable, a static variable of type application context, and let's call it application context. Be sure to import it from the Spring Framework corresponding package. And we'll also need to override the setApplicationContext method, since we implement the application context aware. This method receives the application context parameter and throws a beans exception type. I imported the beans exception. Now we'll use the Spring context dot application context to be equal to the application context received as a parameter in the setApplicationContext method. And let's also return the application context using a static method. And over here we're returning just the application context. Okay, let's move forward and work on the listeners that will be used in our application. We'll have a mouse listener and also a button listener. So let's go under Kong Hangman Game Guy Listeners and create our mouse listener that will respond to mouse events for our buttons that will be created in our course. This mouse listener class needs to extend the mouse adapter. I set up a simple empty constructor for our class. Let's add a comment for the method that we'll set up. Handle the case when mouse enters a specific button. The method needs to be called mouse entered of type void and receives a mouse event as a parameter. We will need to get the button that we selected. Actually, the button that triggered this mouse event. When we enter on the button with the mouse, this event will be automatically generated. So if the button chosen is enabled and we went with the mouse over it to basically hover the button, we need to set the background color as an effect. And let's set it to white so that the user knows on which button he hovered. Now let's add a new method that will handle the case when mouse exits the button. We need to call it mouse exited of type void, of course. Same to the mouse entered, this receives a mouse event. and we need to check if the chosen button is enabled. We'll set a specific background color to this button also. Okay, we set the background color. Let's create a new class called button listener. So this button listener class needs to implement the action listener. Let's also add a method that needs to be implemented, action perform, that receives an action event E. We need to get the current button that we clicked on using the same process, E get source. We'll simulate the fact that we don't want the button to be selected once again, so we disable it, and also set the background color to green. We'll also need to get the button corresponding letter, since each button will have a letter. We'll do this using the getText to char array of 0. This will in fact get us the first and only existing letter to that button that is added to that button. And now, if you recall the application context, the Spring Context class will be used here to retrieve the application context and at a later point in this chapter you will see, once we set up all the buttons in place, how we will be able to use this application context inside our module. Now we are ready to create our third panel in the list. So let's navigate to Hangman Game Guy Panels, corresponding package, and create a Letters Panel class. We should follow the similar approach to annotate this class with the component stereotype, so that it will be picked up by Spring Boot. This class will need to extend the JPanel swing component. Now we'll need to create a specific map that will keep the key value pairs of letter and corresponding button. Since we will try to simulate the entire keyboard of our desktop computer or laptop computer, depends on user's case. So I'm creating a simple map with the key being a string and the value being the corresponding J button, and we will call it letters map. Now for the letters panel constructor, we will set a simple layout of a grid layout, where we will use 3 and 0 corresponding grid layout structure. We'll set in place a create panel method that is annotated with post construct, so that this method will be automatically invoked by Spring. And we'll start to define list of corresponding rows from our keyboard. So the first list will contain all the letters from Q to P inclusive. So I'm adding here all the letters from the Q to P on our keyboard. Let's go with a similar approach for the second row, and we'll set up letters from A to L. Please recall that all letters are uppercase. J, K, and also L. And let's set in place the last row from Z to M. So array is as list Z, X, C, V, B, N, and the final letter M. So we define 3 lists of strings that will keep track of our 3 rows from our keyboard and include all the letters. Now we should add a descriptive comment, such as for each letter in the list we need to create a corresponding button. Now I would like to set up a method that will create a JPanel for each list of letters that will be set as parameter. So we'll receive each of the 3 letters, and based on that on those letters we'll create a corresponding panel, and that panel will have a set of buttons that will match those letters. So I'm creating here a letters panel. This will act as an intermediate panel. We'll want to create a button listener corresponding instance, and let's also add a mouse listener. New mouse listener. And now for each letter in the list we want to create a button, and the corresponding data should be mapped to it. So let's do iteration on the letters list that is received as parameter to this method. And for each letter we will try to create a button that we receive as parameter to the constructor the letter. We will want to create some properties for this button, such as set preferred size, and also set the background color 100. Okay. And now we should add the action listener, such as this button will respond to specific events, and also mouse listener, so that this button will be able to respond to mouse events on mouse enter and mouse exit. And let's also add a specific font to this button. We can create here a variable, and let's call it font. And we will instantiate a new font. But we should not forget about the type. So this is font, the variable name font. And for the font we'll use bold and 26. Let's use the helper class for this, since this is a constant variable. Helper font, so we set the font for our button. And now for the letter button, in fact, let's add a letter button to the letters panel, and we need to also add it to the letters map, so the letter will be the key and the letter button will be the corresponding value, so that we'll keep all the buttons in one place, that is letters map. And since we create this intermediate panel, we need to return it, and under the create panel method we need to invoke the create letters panel for each of our three lists. So let's create a variable called QP panel that will return a panel of buttons from the QP list. Same for the second list from A to L, and also for the third list Z to M. So we have three panels defined, and we'll add these three intermediate panels to the main letters panel using this keyword, since it has a reference to the main panel. Let's remove these spaces. And now we have the letters panel in place. But we will also want to have the setter and getter methods for our letters map that will keep a reference to all our buttons that were added to the letters panel. So this is the get method, and let's also add the set method. Let's do this manually, since Spring Tool Suite IDE can do this automatically, but we can write this down on our own. So this letters map equals to letters map. And let's go to the hangman frame, and let's inject the letters panel. We'll use the auto-wired annotation, private letters panel as the variable, and over here we need to add the letters panel to the main panel, but this time we'll use the border layout dot center, so that we'll add this panel in the center of our screen. And let's start the application. And you can see the panel in place. Also the mouse listener is in place. You see that when I hover a button, the color is changed. Also the action listener is in place. When I click on the button is changed to green. Under this video, we'll create our fourth panel from our list of panels. So let's navigate to our panels package and create a new class. This will be called word panel. We'll annotate this class with the component Spring stereotype, and we'll also need to extend the JPanel class. Let's also add a default serial version UID. We will need to set up a new variable that will be a list of JButton, and we will call it generated word list, so that each letter from our generated word will map to a specific button that will be added to this list. A new variable called generated word that will keep our corresponding generated word, and the number of attempts that the user tried to guess the word. Under this JPanel class, we'll need a reference to the letters panel, so we'll inject it. Also, another reference to the images panel, so inject both of them using the auto-wired annotation. I have created a simple constructor, and over here we will set specific panel properties. I added the set layout as a simple flow layout, the preferred size for our panel, we will need to set the background color to black, and now we will annotate a new method with a post construct, so that it will be automatically invoked by the Spring container, and this method will create a JPanel. So far we will need to instantiate the generated word with a default word, since we don't have anything in place that will generate automatically and in a random fashion words, so we'll go with something simple at this stage. So the generated word will be game, and let's also instantiate the generated word list as a new array list. And the number of attempts should be 0 since we just started the game. Now, since we have a word in place, even if it's the default game word, we need to get the first and last letters from it. So this will be char specific variables. So for the first letter in word, we'll extract it from the generated word dot char@, of 0. And for the last letter in word, we'll get the generated word char@ generated word dot length -1. So now we have both the first and last letters in the word. And we'll need to iterate over the generated word and create a button for each letter in the generated word. So final J button, let's call it LB, is instantiated to new J button, and by default we'll use that sign to simulate that the letter is not shown to the user. We'll set the button preferred size and also the button corresponding font. Also, let's set the background color to white and do not enable it. It should be disabled by default so that it will not respond to any click events or mouse events. We'll add this button to the generated word list and also to the corresponding panel. Now, since we have the first and last letters extracted from the generated word, we need to also show them into the graphical user interface to the user, since, as you know, we are doing a hangman simulation and the first and last letters of the words should be exposed to the user. So I expose the first letter. And also let's expose the last letter to the user using the setText method. Now we need to iterate over the generated word using a for loop. So for int I equals 0, I lower than generated word length -1, I++, and we need to get each letter from the word. Let's also add a comment here. And what we're trying to do here is to expose the current letter to the user if the current letter matches the first letter from the generated word or the last letter from the generated word. So if current letter equals to first letter, or current letter equals to the last letter, we need to get the generated word list, the corresponding button reference, and set the text to the current letter. Okay. And now we need to disable the letters that are initially exposed in the word that we generated. So in this way we need to disable the first and last letters from the letters panel, since they are already exposed to the user and the user should not be able to click on them. So let's navigate to the letters panel and create a method here, and let's call it disable default letters. And this method should receive the first letter in word and also the last letter in word. So let's create some strings based on the two chars that we received as parameters, for the first letter and one for the last letter. Okay. And now we should disable the first letter. We need to get a reference to the first letter in word button. And for this, if you recall, we have the letters map that has references to all our buttons. And we'll get the corresponding button using the first letter dot uppercase. So based on the letters map key, we will be able to extract the corresponding JButton value. And we need to basically disable this button and also set the background color to green to simulate it in a way for the user. And a similar approach should be followed for the last letter that we receive as parameter for this method. So we will create a last letter in word button. And from the letters map, we'll get the last letter dot to uppercase. Let's fix this. Okay. So we have the corresponding JButton value, and we need to disable it and also set the background color to green. So let's do this. Set background color green, and that's basically it. So let's go back to the word panel and invoke that method. So we have the letters panel reference that we injected earlier in this component, and let's call the disable letters panel using the first letter in word and last letter in word. And now we should return the panel that we created from this method. As a next step, we need a method that will check if a selected letter is present in the generated word. For example, when we will select a letter from the letters panel, we need to check it if it's present in the generated word or not. And based on this, we'll do something. So let's set up a boolean value at letter found by default will be false, and iterate over the generated word. We need to get the current letter from the generated word dot chart of I, and we need to check if the current letter matches the letter that we selected. And if so, we'll invoke the generated word list that get of I set text string value of letter. So we'll expose the selected letter since it's found in the generated word. So the selected letter will be exposed to the user, simulating the fact that he was able to find the letter. And since the user was able to find the letter, maybe you are on the case that the entire word has been found. So if the letter was found, however, we should not forget to change the letter found with true. Okay. So if the letter was found, and we'll also need a method check completed word to see if all the letters from the generated word were found. So let's implement this check completed word, a simple method. So let's add a comment check if all letters in the word have been found. So this is a private method. Check completed word, and we will need the mechanisms to figure out if all of the letters from the word have been found. And in order to do this, if we have at least one of that symbols that simulate that the letter is not shown to the user, it means that the word is not completed. So let's do a search on how many letters with that symbol we have in the generated word left. So number of letters found, we'll extract from the generated word list. We'll do stream filter, and for each button we check that the button text is equals to that symbol and do a count. And if number of letters found greater than 0, it means that the word is not completed. But in fact, let's change this variable to number of letters not found, since it's more descriptive. And if all the letters were found, we will return true. So going back to this statement, if letter found and check completed word, we will need to invoke the letters panel and get the letters map, and for each letter in the letters map, please recall that the keys are strings and values are J buttons. So for each button, we'll disable it so that the user will not be able to click on any button in the panel anymore. And also we should show a pop-up message using the J option pane, show message dialog, and let's inform the user that he was able to find the word in this case, and let's congratulate him. And let's go on the else case. If letter found it's not true, so the user was not able to identify a letter, we need to simulate this in the graphical user interface. So if you recall the list of images, we need to update an image reference from smile to sad. So we'll do this using the images panel, and on the images panel we need the reference to the images list. So we'll need to create the getter method for this under the images panel to have a reference once again to those 5 images that are used to simulate 5 possible attempts to the user to guess the entire word. So this will return the images list, and let's also add a setter method for this. Set images list that will receive a list of a J label, and this images list equals images list. So going back to the word panel, we have access now to the get images list. And we'll get the current attempt. Please recall that the number of attempts is 0 when we start the game, and we'll set the icon. We'll in fact change the icon from a default smile image to a sad image. We'll also increase the number of attempts. And since we increase the number of attempts, we should also check if we reach the maximum allowed attempts. So in this case, the maximum number of attempts is equal to the images panel get images list size, in our case 5. So if so, we'll iterate over the get letters map from the letters panel using the same approach described earlier, and we'll disable all buttons in order to disallow the user to click on any buttons left, and we will also inform the user that he was not able to find the word, meaning that he lost the game. So the word was generated word. Okay, so far so good. This looks good. And if you recall, we set up here a check letter method, but we don't call it actually. But we have an action listener for each of our buttons. And now under the button listener, we need to invoke that check letter method using the Spring Context class that we defined earlier. So we need to get the instance of the word panel. Since you see that the button listener is not a Spring component and the word panel is a Spring component, and using the Spring Context class, we will be able to properly invoke the method from the word panel using this button listener. So you see the word panel, check letter of letter. So now we will also be able to invoke Spring corresponding beans from a component that is not associated to the Spring container. The last step will be to auto-wire the word panel under the handman frame and add it in the main panel under the north section. So let's do this. And let's also start the application now. We save the word panel. And you see, by default, we have all panels in place and that default game word. You see that attempts are in place from a smile image. A sad image has been updated in the images panel. We have the game in place, but it seems that we don't have any option to regenerate the game once we finish it with success or failure. So let's work on this. We need to work on the panels, and for the empty panel you don't need to do anything since it's just an empty panel. But starting from the images panel, we need to create a way to regenerate the components on the screen. So let's set up a simple method, a public void clear method, and under this method we'll first remove all the components from the images panel and also reinvoke the create panel method that will basically create all components and add them to the panel. Let's follow the same thing for the letters panel. So public void clear, this remove all, and let's reinvoke the create panel method. And the same thing for the word panel. Public void clear, this remove all, and this create panel. So we now need a way to actually call all these three methods from the images panel, letters panel, and word panel. So let's go under hangman frame, and at the bottom here we'll create a private void clear panels method. And if you recall, the hangman frame has references to all our panels, and we'll invoke the clear method for letters panel, word panel, and images panel. And we'll also need a method that will be called new game, and under this method we'll first dispose the current JFrame. We'll need to get the X and Y coordinates from our current JFrame position, and we'll also need to invoke the clear panels method so that we'll clear and regenerate the panels. Once we've done that, we will set the location for our JFrame and set it back to be visible to the user, with all the panels being regenerated in a correct way. Now we need to somehow invoke this hangman frame new game method, and we'll go under the word panel and have an instance to the hangman frame. This is a component, so it can be injected. So we have two locations where we can generate this new game. In the case that the user has found the word, and also in the case that the user was not able to find the word. Now everything should be in place, and we have the option to regenerate the components, basically to restart the game. You see that the game has been restarted automatically, and all panels were regenerated with success. Under this video, I would like to implement a mechanism that will allow us to extract random words from a database instead of using the default game word each and every time. So as a first step, we need to go under pom.xml, and over here we need to add some specific dependencies. So the first dependency will have the group ID org spring framework dot put, and for the artifact ID spring boot starter data JPA. And now the second dependency will have the group ID MySQL, and for the artifact ID we need to set up the MySQL connector Java. So since we have this dependency in place, we will need to go under com hangman game model package and create a simple class, and let's call it word. So this class will act as a JPA entity and will allow us to interact with the database. So let's annotate it with entity. Be sure to use the Java persistence entity package, and let's also add a table name as being the words. We'll now need to set up a specific variable that will act as a primary key for our words table. So we annotated it with the ID, and the generated value we'll use generation type strategy as the identity. So let's do this. Now let's add a private long ID variable. And I would like to also set up a private string value. But first let's annotate it with column length 16 and unique true. We will now add a public constructor, a default constructor that is required for JPA entities. And let's use the IDE to generate the getters and setters for our value field. Okay, the next step is to create a corresponding word repository. So this is related to our Spring Data JPA. So this needs to be annotated with the repository stereotype. And of course, it should extend the JPA repository. And as parameters, we need to set up the model class and the type of the primary key, in our case long. And for the model class, of course, the word class. The next step will be to create a service for our interaction with the business logic and our JPA entity. So let's call this service word service, and let's set it up under com handman game service package. So let's change it to an interface, and we will define two methods. One that will store a list of words into the database when the application will run first time, and another method is to extract a random word from the database. So we'll need a concrete class implementation to actually implement these methods. So I created word service IMPL and annotated with service stereotype, and this class implements the word service interface. Let's also add a unimplemented method so far, and let's also inject the word repository. And for the list of words, I already prepared for you a list of 1000 words that will be stored to the database, so you just can copy paste this without writing them down. You see there are many words that you can play with. and we need the mechanisms to actually store this list of words. So under save data in DB method, we'll first check if the word repository count method returns 0. This means that we don't have any words stored so far in the database. We'll split the word list into an array, separated by comma, of course. And we'll iterate over this words array and save each word into the database using the word repository save method. So for this, let's create a simple constructor that receives the value as parameter. So this value equals value, and this should fix our problem. We'll store directly a word into the MySQL relational database. Let's move now to the getRandomWord method, and for this, let's go to the word repository and set up a specific method. So this will return a word, and let's call it find random word, and we'll use the query specific annotation and do a select from let's call our database hangman, since the game is hangman, and invoke the hangman words, order by rand, limit 1, and native query should be set to true. So this will extract a random word from our hangman database that we'll configure later, and from the words table that we configured earlier in the word corresponding model class. So going back to the word service IMPL, let's use the newly created method from the word repository. So word repository, find random word, and let's retrieve the string value using the getValue method. Now, since we have these two methods in place, we'll need a way to actually invoke them. So for the first method, let's go to the game application, and over here, when the application will start, we will first inject the corresponding service using the auto-wire annotation, and of course using the postconstruct method. Spring will automatically invoke this method, and at this stage let's do a save data in DB call from the word service. In this way, all words will be stored into the database. Now we need a way to invoke this getRandomWord method, and if you recall, on the word panel we set by default that game as being the generated word, and we need to change this. So let's auto-wire the word service instance, and instead of using the game text over here, let's use the word service getRandomWord method. So each and every time we'll generate this panel, a new word will be extracted from the database. Now an important step is to set specific properties under our application properties file, so that Spring will be able to communicate with the MySQL database. So we'll set the Spring Data Source driver class name as the class name that corresponds to the MySQL instance. We need to set the Spring Data Source URL, so this URL matches the MySQL instance that we set up locally and connects to a Hangman database that we'll create. For the Spring Data Source username, we have the MySQL instance username set to root and the password set to password. Of course, this depends on your MySQL instance. We will show the SQLs that are generated in the logs, and we will use the DDL auto update in terms of possible changes that we'll do to the word model class to be automatically stored under the MySQL corresponding instance. Now let's set the MySQL dialect. So org hibernate dialect, and let's store the file MySQL SQL 57 dialect. Now I went to my MySQL instance, and all you need to do is create a simple database called Handman, one time only. And let's start the application. And let's look at the logs. You see that all words are being inserted. This process happens only one time, and you see that already we have a random word extracted from the database in the graphical user interface. We can also review the fact that all words have been inserted into the database using a count from the words table. And you see 1000 words. And now the game works much smoother in terms of being able to generate random words each and every time. You see long words, short words, and so on. In this video, I would like to add the option to provide a menu for our graphical user interface. So let's close the current instance of the application, and under com handman game guy menu, let's create a simple class called menu. This class will be annotated with the component Spring stereotype. Should extend the JMenu bar. This is a component from a Javax Swing package. Now I need to auto-wire the handman frame main component. Let's fix this and remove the comments. I'll create a constructor for our menu class. And after this, we'll set up in place a create menu method, and under our constructor, let's call this create menu method. So under this newly created method, we'll first define a J menu called options menu, and we'll store the option string next to it. And now let's create some simple menu items that will be added to the options menu. So for the option 1, we'll have the possibility to generate a word, and for the second option, we'll have the use case to exit the application. So this is an alternative way of pressing on the X button. Now I would like to add also key listeners to our J menu items. So Ctrl+N for the new game option and Ctrl+E for the exit option. So let's do this. So option 1, we need to invoke the set accelerator, and as parameter we need to set the keystroke, get keystroke, and key event dot vkey and n, and we need to add the action event as control mask. Similar for the option 2 of our menu. Set accelerator, we'll still use the keystroke, and now we'll use the key event with E, and action event, same thing, control mask. We'll need to implement the business logic for our options, so we'll add action listeners for both of them. So for the option 1, for the generate word, we'll need to implement the action perform method, and receives an action event E, and over here we use the instance from the Handman game and evoke the new game. And for the option 2, we'll add an action listener, same method signature, action performed, action event E as parameter, and this time we'll exit the application. Now we need to add both option 1 and option 2 to the options menu. And add this options menu to the main J menu component that this class extends. In order to properly use this menu, we'll need to inject it under the Handman frame. So let's do this. We'll need to first use the auto-wired annotation, private menu, since our class is called in this way. And over here we'll invoke this set J menu bar, and for the parameter we'll use the menu. Now we will start the application. And you can see that the options menu is present with two different options: generate word and exit. I pressed on the generate word, a new word has been generated, of course, and you have also the option to use keystrokes. Let's use them for the exit option.